So every once in a while you run into people arguing that because evolution is demonstrated in a computer program, that means that it makes the process valid or more scientific. Um, Actually, it's almost, with some people, it's almost like they think that because evolution was simulated on a computer program, that proves that it's a real process. The problem with this, of course, as anybody who thinks about it logically, is kind of obvious. I mean, just because something's simulated on a computer program doesn't mean that it's real. As computer programmers say, garbage in, garbage out. If the assumptions going into the computer program aren't good assumptions, or if they don't reflect real life, then you can end up with a faulty model or faulty computer program. You could potentially have a computer program where you take a little stone, throw it at a mountain, and the mountain goes and flies off into the ocean. By putting faulty physics into the computer program, or by, but that doesn't mean that that's science. That doesn't mean it reflects what's going on in the real world. I mean, there's computer simulations out there of a boy with a scar on his head flying around on a broomstick trying to chase a little ball around. I mean, just because you can simulate in a computer program doesn't mean it's real life. In video games, just about any video game out in the world, I mean, those are computer simulations. Doesn't mean they reflect the real world. I mean, I can't go around, as much as I would like to, I can't go around catching wild animals and putting them into a tiny ball. And saving them and having them be my pets, my friends, and going around battling my friends. If anybody has played the game Portal 2, I can't take that game. It was interesting because it seemed like they simulated the physics quite well. I only took physics in high school. I haven't had to take it at the university level. Of course, I'm told it's kind of a rite of passage if you want to go for genetics. So I'll probably have to take it. In that computer program, it seemed like they simulated inertia and things like that quite well. With the assumption that you could have a ray gun that makes two portals where you jump in one end of the portal and come out the other. For those of you who don't know, that's the premise of the game, is that you're solving these different puzzles. You have a ray gun that shoots two portals, so you jump in one opening and you come out the other. So it's kind of like if you were to shoot a hole in this wall, and shoot a hole in that wall. If you were to run through the hole in that wall, you'd come out that wall. And if you put one in the ceiling and one on the floor, and you jump in the one on the floor, you can end up just keep on following, and you can basically have this go on indefinitely. And that's one of the more fun things to do in the game. Great game. Anybody wants to play Portal 2? But anyway, that is a computer simulation, but is the idea of using a ray gun like that valid? Does this reflect the actual real world? And as far as we know, nobody has ever built a portal gun. So that'd be the obvious scientific problem there. Now, when it comes to simulating Darwinian evolution, there's a lot of assumptions that go into it. I mean, I just watched the documentary Blind Watchmaker a minute ago, and it seemed interesting because anybody who's familiar with it, you'll know that Dawkins has a couple different computer programs he uses in there. One of them is a computer program that takes a string of letters, and they're trying to generate a target. They're trying to generate methinks it is like a weasel. And if a letter, if you have the first letter, then it's an A, then it'll tend not to preserve it. If it's a B, it'll tend not to preserve it. It'll only preserve it if it's an M, in other words, if it's the desired outcome. And gradually, kind of like a rigged slot machine, you will gradually end up developing the sentence methinks it is like a weasel, because if you get the right letter, then it tends to not spin that. It tends to keep it. It has a great number of odds of keeping it. But if you don't get the right letter, then it'll just keep on going. So gradually you end up developing methinks it is like a weasel. Now I look at this from a genetics perspective, and of course Richard Dawkins was kind of honest about where he said, at least where he says, he said at one point that, this is goal directed, whereas evolution is not. But I think there's a lot more problems to what he's claiming that this shows than just that, because genetics is not a rigged slot machine like that. Yes, beneficial mutations tend to be preserved, but if you're trying to construct a gene, for example, genes have to have a particular sequence in order to have a proper function. One of the major problems with genetic diseases is by taking a functional gene, by slightly altering it, very often you can destroy the function of that gene. And genes, like anything else, can tolerate a little bit of damage, just like a car can tolerate a few dents and bruises. Dents and dings because it's a car. But if you take a car and you totally smash something with a boulder, it doesn't survive. Same thing with a gene. I hope I'm not overextending my analogies here. But a gene is a similar thing. You might have 3,000 different nucleotides, 3,000 different letters, all strung together, and they spell out the instructions for building a protein. They spell out the blueprint for the protein, and that has to be just about perfect in order to function at all. You can change it a little bit, but if you change it more than slightly, the whole thing falls apart. And Dawkins pointed out that getting even one line of Shakespeare would take, by random chance, that would take more than the entire lifetime of the universe so far. So now that was just getting one line of Shakespeare. The odds of getting one full gene by random chance, which you would have to have in order to have a functional gene, would be about the odds of getting a full page of Shakespeare. Now, evolutionists will say, well, there were older genes that this one came from by gradually modifying one at a time. The gradually baby steps, you went from gene A to gene B to gene C to gene D, etc. That's their claim. But when you go down to the bottom line of it, get down to the very core of it, in order to have even one fully functioning life form, you need to have hundreds of different genes. I plan to make a video later on about the minimal gene set concept. But basically what scientists have found consistently is that you can't have 10 genes or whatever and have a functioning biological entity that survives on its own. Perhaps a virus, viruses would be like that, but they're beside the point because even a virus needs the machinery of a cell in order to survive. In order to have a functioning independent life form, in order to have the alleged first life form that would have existed on Earth, the most primitive possible cell that you could have, requires hundreds of genes just to survive. People have speculated that, well, maybe there was a self-reproducing molecule out there, but there's no evidence for that. So in order to get one gene, that'd be about the odds of getting a page of Shakespeare in one hit. But you don't need just one page, you need hundreds just to survive. Just to have the most basic functioning cell. And you know what? Let's just take neo-Darwinism at face value, and we'll just for the sake of this, for argument's sake, we'll just go with the idea that you can go from gene A to gene B to gene C by these gradual processes. We'll say these really are baby steps. I've argued in other videos that a lot of these genetic changes that would be required would be jumping over canyons. They're not baby steps. And a lot of what Darwinists present as baby steps are really like the cow leaping over the moon. They're not baby steps. They're huge, grand leaps strung together. Not a bunch of baby steps strung together. They're massive, massive, incredibly giant leaps all strung together. So that's one of the major problems with something like Methinks It Is Like a Weasel. Also, in the same video, Dawkins had what are called biomorphs. So there are these things on a computer that look kind of remotely like a living thing. They look kind of insectoid. But all they are is little computer programs with some random lines put together to look kind of like an insect. and you gradually click on one at a time, and it ends up becoming the parent of the next generation. Each individual night generation is a slight variation. And in The Blind Watchmaker, in the movie, I haven't read the book, Dawkins goes through this process and shows how you could gradually develop something that looks like a scorpion. But of course this is kind of silly, because this is not a real scorpion. This is just something that kind of vaguely, superficially looks like a picture of a scorpion. It doesn't show how an actual scorpion could come about. An actual scorpion is incredibly biochemically complex. Going from a worm to a scorpion in real life, it's quite difficult. It's quite a bit different than this computer simulation. You know, computer simulations are all well and good. Even if Darwinism's true, even if everything the creationists have said right along is wrong, a computer simulation does not prove evolution. All it proves is that you can simulate this hypothetical process on a computer and end up with your desired outcome. The problem is, do these simulations reflect real life? And I would argue that no, they really don't. We've never seen living things develop a fundamentally new biochemical pathway. That's kind of been my line that I've said a lot in these videos, especially lately. Even with studying E. coli for decades, we haven't seen the development of fundamentally new biochemical pathways that weren't there before. And for E. coli, 2 years worth of time is the equivalent of about a million years in human generations. So E. coli go through the same number of generations in about 2 years that it would take human beings to go through in a million years. So evolutionists can't hide behind the evolution takes millions of years excuse. They really can't do that, especially in these days where we have genomics, we have we have quite a bit more understanding of molecular biology. We can sequence things very, very quickly. They really don't have the millions of years excuse anymore. And a lot of these simulations, they're interesting, and at best they would say, oh, Darwinian evolution is intellectually plausible if this long list of assumptions is true. The problem is, are these long list assumptions real? Can you go from point A to point B through baby steps? Sometimes you can, but a lot of times you can't. Creationists agree with evolutionists that mutation and natural selection can do a lot, but we don't agree that these grand claims that they've made really hold their weight. So anyway, I go into more detail with those things in other videos. This video is just meant to be about computer programs. They have obvious fallacies, and if you don't have accurate information going into the computer program, if your assumptions have flaws, your outcome is going to have flaws. And of course, designing a kind of ad hoc computer program to simulate Darwinian evolution, well, these computer programs were designed to make it where Darwinian evolution would work in the computer program. It doesn't prove that it works in the real world. And anybody who, if I were sitting with Richard Dawkins right in front of me and I were to really press him on the issue, I'd probably say, Mr. Dawkins, of course, these programs they're kind of silly. Brilliant that he wrote them. I definitely take my hat off to him. I couldn't write something like that. But I'd say, Mr. Dawkins, these computer programs are, all they are is computer programs. I mean, we can simulate a computer program to do anything. We can simulate Harry Potter flying around on his broomstick, and we can even put real physics into the process. But you'd still be having garbage in, garbage out. I'm not saying this computer program's garbage, I'm just saying what the saying says. If I were to really press him on this issue, I think his reply would be, well, yes, of course, these computer programs they may not may not reflect the actual complexity of living organisms. However, they are representative of a real biological process. And I think that's what the type of answer he would give would be. But computer programs by themselves do not prove that Darwinian evolution can have. We need to show that empirically in the laboratory, and so far nobody has ever shown how fundamentally new biochemical processes could come about by chance, and that's by chance mutations plus natural selection. I don't want to be accused by some troll of giving a straw man argument here. We don't see where fundamentally new classes of genes come about. You might see genes have slightly different versions via mutation. We've seen nylonase, which is just a variation of protease, and nylon was designed based on protein structure, so it's really not all that surprising. That's what we see. We see change, we see shifts in allele frequencies, we see mutations that destroy enzymes and result in antibiotic resistance. We see mutations in enzymes and fruit flies that end up resulting in a different eye color because they end up destroying the enzyme, and therefore you end up with a different eye color. We don't see those fundamental types of changes that Darwinism would require. We don't see the increase in genetic information. Duplication of existing information we see. We don't see increase in information. We don't see new biochemical complexity, new specified complexity in a coded system. That we don't see. And those are some of the real problems that computer programs like Methinks It's Like a Weasel, Dawkins' program, don't really address. You need to have a gene there pretty much all at once, otherwise it doesn't work. And you don't get much leeway in the system. Anyway, thank you for your time, thank you for watching this video, and I really hope that nobody falls into this logic of, well, we simulated on the computer, therefore it's reality. Anyway, check out my websites. greenslug.com is my blog. blueslug.com is a science search engine that I'm developing. As a biotech major, I designed this for other biotech students, but it's great if you're a geologist, physicist, anything. Whatever you're studying, blueslug.com is a great science search engine. And there's also a journal search engine on there if you're a researcher or if you're a upper level student who needs to find journal articles on HIV, or on if you're looking for something like you're looking for anything related to molecular biology, the journal search engine is great. Even if I don't care what field you're in, try it, see what you think, send me an email. If you're in kind of a field that's a little more removed from molecular biology, like you're in applied psychology, please, send me an email, let me know, and I'll try to improve the search engine for you. Alright, this is Greg, out.